Bismillahirrahmanirrahim. Exercise 7.3, and it is about scalar product or dot product of vectors. Let's revise what is scalar product. If we are given any two vectors, then their scalar product or dot product is written as u dot v, and it is simply taken as the product of their x component plus the product of y component plus the product of z component. You can see here the coefficient of x1 of a unit vector I, that is a1 and a2, these are multiplied, coefficient of unit vector j b1 b2 plus coefficient of unit vector k c1 c2. So the formula for u dot v becomes a1 a2 plus b1 b2 plus c1 c2. We also have u dot v is equal to u v cos theta, where u is the magnitude of vector v and v is the magnitude of vector u. U is the magnitude of vector u and v is the magnitude of vector v, and theta is the angle between u and v. And from here we can find the formula for cos theta, which is u dot v divided by magnitude of u into magnitude of v. Now let's start this question. The question is to find the cosine of the angle theta between u and v, where vector u is equal to 2, minus 3 and 1, and vector v equals to 2, 4 and I. Let's start the solution. First of all, I'm going to write these vectors with the unit vectors I, j and k. So this vector u, which is equal to 2, minus 3 and 1, it becomes 2 into unit vector I, minus 3 into unit vector j, plus 1 into unit vector k. So you may simply write it as k. Then vector v, it is 2, 4, 1. So it becomes 2 into unit vector I plus 4 into unit vector j plus 1 into unit vector k, or you may simply write it as k. Now let's find u dot v. First of all, u dot v will simply become product of the coefficients of unit vector I, that is 2 into 2. It's your choice. You may write directly as 4 plus minus 3 into 4, minus 3 and 4, or you may write minus 12 directly, then plus 1 from here and 1 from here, or you may write directly 1. Result 4 minus 12 is minus 8, and then plus 1 minus 7. So I get u dot v is equal to minus 7. Now let's find the magnitudes of vector u and v. The magnitude of vector u, it can be written as, now I have to write the magnitude of vector u, so I can write it as u, or if you want to write it like this, you may write it like this. And the formula is square root of coefficient of unit vector I square, that is 2 square, plus coefficient of j square, that is minus 3 square, plus coefficient of k square, that is 1 square. So it becomes square root of 4 plus 9 plus 1. As a result, I get 9 plus 1 is 10 and 10 plus 4 is 14. So the answer is square root of 14. Let's write the magnitude of vector v. It can also be written like this. Square root of 2 square plus 4 square plus 1 square. That is 2 square plus 4 square plus 1 square. 2 square is 4, 4 square is 16, 1 square is 1. So I get 16 plus 4 is 20, and then 1, that is 21. So this is the magnitude of vector v. Now let's write the formula for cos theta. We know that cos theta is equal to u dot v divided by, only one dot here, u dot v divided by u v, and that's it. U dot v divided by u v. Let's put in the values. U dot v is equal to minus 7. U is square root of 14. V is square root of 21. Combine the two under one radical sign and you will get 14 into 21. Let's factorize these. Minus 7, 2 into 7 into 7 into 3. And you can see we have got 7 2 times here. So it can go outside the radical sign. So I get minus 7 by 7, and inside I have 2 multiplied by 3, so I'm writing it as 6. Now cancel this 7 and you will have your required result. Cos of theta is equal to minus 1 by square root of 6, and that is the answer.